Hey everyone! In this episode, Physics in the Flesh is starting Energy and Work Problems. Work and Constant Force 1. A 1400 Newton crate rests on the floor. How much work is required to move it at constant speed? A. 3.5 meters along the floor against a friction force of 235 newtons. And B. 4.0 meters vertically. Okay, so this is the theory behind what we're doing. Assume a person is just trying to pull a crate with a certain force Fp for pull. Okay, that force is making an angle theta with the direction of the displacement in the x direction. Okay, to find the work done by the pull force, you just simply multiply the force of the pulling times the displacement the box undergoes times cosine of the angle between the displacement and the force. Okay, so that's the idea here. That's just for the work done by the pulling. So what I want to do first here is draw a free body diagram so we know what forces we're dealing with here. Okay, so let's do that first. For part A, we're working horizontally. Okay, we're dragging the box across the floor. Now, because it's on the floor, there is a normal force. And that normal force is, of course, counteracting the force of gravity, which goes down. Okay, assuming the box is being pulled forward, we're going to let this be Fp for F pull. And there's a frictional force opposing its movement, so we'll call that Ff going back. Okay, so that's what we're dealing with here. Now we should also define our positive direction. So let's make a coordinate system here for part A. There's our y, there's our x, and both of these will represent the positive directions. Okay, so one of the key words in this problem is that we want to find out the work required to move it at constant speed. Whenever you see constant speed, it should ring a bell. Okay, constant speed implies that the acceleration in the x direction is 0. And if that's true, that also means that the net force in the x direction is also 0. Okay, in other words, the two forces in the x direction must be equal in magnitude, opposite in direction. Okay, so therefore we can say that Fp is equal to Ff, which is equal to 235 newtons. Okay, so therefore 1400 crate across the floor. If this is the frictional force, that is also the force required to pull it at constant speed. Okay, now just like we saw in the theory, we want to know what direction the displacement is. And in this case, the displacement is forward. Delta x is going like this. Okay, so the angle between the push force and the displacement is 0. If you look at these two, theta is equal to 0 degrees. The work is what we want, the work done by this force. If we were asked for the net work, we would have to find the net force first and then find the angle between that direction and the displacement. But here we're just looking for the angle between the pull force and the displacement, which is 0. Okay, so let's start making our formulas. So the work done by the push force is Fp times delta x times cosine theta. Okay, so Fp delta x cosine 0 degrees. Okay, my Fp is 235 newtons. I just established that up here. Okay, it's being dragged 3.5 meters across the floor. Cosine of 0 is 1. Okay, so if you don't know that, you should really look into the graph of cosine. So 235 times 3.5, you end up with 8.2 times 10 to the 2 joules. So this is the work done by the pull or push force in this case. Okay, so that's for part A. Part B says we're going 4.0 meters vertically. So a little bit different scenario here. Okay, so for part B, we need a new free body diagram, obviously, because this one's not going to suffice. So here we go. We've got our box, and this time it's being pulled up vertically. So here's my Fp now. And of course, there's still a weight, so there's an Fg going down. Okay, now in this question, I want to establish a new positive direction. Because the box is going up, I'm going to let up be positive. So positive y is going up. And I do my same formula. Okay, so the work done by the pull force is equal to the force of pulling times the distance it's going, delta y, times cosine of theta. So identify the direction that the displacement is. And in this case, the displacement delta y is going up like this. Right, so in the formula, in the theory, we said delta x, but really it's the distance you're going. In this case, it's in the y direction. So the angle between the pull force and the delta y, theta is equal to 0 degrees. So that's going to work out nicely again because we once again get cosine of 0 is equal to 1. Okay, so that disappears. Now, you might say, I wasn't given the pull force in this question. Okay, so you look at this. We're still moving at constant speed like we're told in the question. And we're told that the weight of the box is 1,400 newtons. So if we're moving at constant speed, and we can say that F net y is therefore 0, since acceleration in the y is 0, therefore Fp has to equal Fg, which is equal to 1,400 newtons. Okay, so that's where we get that from. Okay, so plug in your numbers. Fp is 1,400 newtons. My delta y is 4.0 meters. Cosine of 0 is 1. 1,400 times 4 is 5,600. And that's going to be in joules. Okay, so let's express this in scientific notation, make it look a bit cleaner. 5.6 times 10 to the 3 joules. Okay, so there you have it, guys. It takes a lot more work to lift this crate than to drag it across the floor. Okay, so I hope you guys enjoyed this video. If you did, be sure to smash that like button. And stay tuned for more energy and work problems, specifically video 97, Work and Constant Force 2.